Let us interpret some more formulas. So we know that shear stress formula for beams is given by tau is equal to shear force V multiplied by Q divided by I multiplied by B. V is in Newton, Q is in mmQ, moment of inertia is in mm raised to 4 and width is in mm. So this is nothing but Newton mmQ that we have written in the numerator. Mm raised to 4 into mm, that is mm raised to 5. Mm cube and mm raised to 5 will get cancelled out, so that you will get in the denominator it is mm square. Now Q is known as first moment of area, that is area multiplied by distance. So A dash is the area which is in mm square. Y bar is the distance, it is in mm. So mm square multiplied by mm is nothing but mm cube. Maximum shear stress is given by 3 multiplied by shear force divided by 2a. Shear force is in Newton and area is in mm square. So again it is Newton per mm square. That is the formula for maximum shear stress in case of the rectangular beam. For the circular beam it is 4 into V divided by 3 into A. V is the shear force, it is in Newton, and A is the area in mm square. So it is Newton per mm square. So that is the unit of the shear stress. Average shear stress it is given by force upon. The shear force is in Newton and area is in mm square. Newton per mm square.